All right, so first let's start off by figuring out when do we use what. We're going to have two laws that we're going to use in this section. One's going to be the law of sines, one's the law of cosines. Yesterday, we spoke about using the law of sines, and what were the situations that came up with when we used the law of sines? Anybody remember?
Solve
It was,
to get when you need.
yeah, like angle, side, angle. What was the other situation that came up? Yeah, angle, side, angle. Then there was this angle, side, side. That was a special case, right? What do we call this one? That's the ambiguous case, right?
Side, angle, side.
Nope, not side, angle, side.
What is it?
Angle, side, angle.
Oh, we got that one? Angle, side, side. Oh, we got that one?
Angle, angle, side.
Angle, angle, side. Okay, there you go. Okay, so we use these ones for when we have the law of sines. Okay. Now with the ambiguous case, there were three possible scenarios. There was either one triangle, two triangles, or no triangle. So keep that in mind when you're doing the ambiguous case and you're given angle, side, side. That's when we use the law of sine. On the other side of this little talk here, for the law of cosines, we use this whenever we are given this information of an oblique triangle, either side, angle, side, or what's the only one left? Side, 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 okay? So whenever you're given side, angle, side, or side, 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 we're going to use law of cosines. And then when we're given the other ones, we use the law of sines. So we have to know that right off the bat when you use what.
Do you not use hypotenuse?
Hypotenuse leg is used for a right triangle, and these are all oblique, right? Yeah. Angle, angle, angle is not one, no. We don't have that one. Although we could use that for a law of cosines, actually. Okay, so what is the law of cosines? The way that I have it written up, and I bet this is the same box here. So I either have law of cosines solved for sides, or I have the law of cosines solved for angles. All right? Now, before we dive into that, let's remind ourselves how we draw the picture of the triangle. So I'll draw it over here to the side. Right? If this is angle A, this is angle B, and this is angle C, across from angle A is side A, side C, and then side B. So you have to know that part right there. So let's talk about the sides, solved for the sides. So it could either be one of three cases because we have three sides. 1, 2, 3. So the first one, if I solve for side A, it's going to be this. A squared is equal to B squared plus C squared minus 2BC times the cosine of angle A. Now I realize that looks kind of funky and weird. It is our law of cosines, and it's solved for side A. But it's actually not too bad. So we're actually developing here the law of cosines, so I'll write that in for you. Law of cosines. But the way that I teach it is I teach it broken up either into sides or angles. So law of cosines, here it is, right? This side A, and this angle A, those are always going to match. So the side and the angle opposite it will always go together on the bookends of the equation. Then the other two sides will always be added together, and they will match right there. Okay? So that's just all this is like a way of remembering what the law of cosines is. We don't have time to actually develop it like we did the law of sines, but it's not that bad. So, depending on which side you want, that's the side you choose. So, I bet you guys could write down for me the equation for the law of cosines solved for side B, if we follow it. So, B squared has to be, what are the other two sides going to be?
A squared plus C
Very good. A squared plus C squared minus 2 AC times the cosine of what angle? Cosine of B. Very good. Awesome.
The side B equals angle B?
No, the little b is the side and the big B is the angle.
Okay, so why do they have to match?
That's just the way that the cosine, law of cosines is worked out. Does that make sense?
Like, what does it mean that they're matching? Like, they have the same value? Or?
Matching. What do you mean by... Okay, can you write down this one? Then C squared would have to be what? A squared plus B squared minus 2AB times the cosine of what? Cosine of angle C, right. So notice again, right, this side matches across from that angle, this side across from that angle. So right here, this is your law of cosines when you are solving for a side, right? But what if you're solving for an angle then, right? So these also have 3, 1, 2, and 3. So basically, if I want to solve for the angle, I want to solve for cosine A. Then I just move everything to the other side, and you end up with this. The cosine of angle A is equal to A squared minus B squared minus C squared all over negative 2BC. So I'm laying out each individual piece of the triangle for you. I'm laying out each side, A, B, or C, and each angle, cosine A, cosine B, cosine C. So therefore, let's do the other two just quickly here. Cosine of angle B would have to be B squared minus A squared minus C squared all over negative 2AC.
Will we have a type of toolkit or something similar for this?
No, you don't need it for this one. Cosine A, cosine B, and then finally cosine C is just going to be C squared minus A squared minus B squared all over negative 2AB. Okay, so here's a typical problem. I give you some information. I'm not going to say, you're not going to be told, use law of cosine or use law of sine. You kind of have to know when to use what, okay? So that being the case, then I suggest the first thing that we do is we draw the picture that represents all the information that we have, okay? If this is A, B, and C, little a, tiny b, tiny c, okay? So what do we know? We know that this value here is 60 degrees, right? What else do we know? We know that this one over here is 3 inches, and we know that this one over here is equal to 2 inches, right? So look what kind of a triangle have we been given. We've been given a side, an angle, and a side. So this triangle is a side, angle, side triangle. Therefore, when I go back up here and I look, oh look, side, angle, side, I'm going to use the law of cosine. Is that fair enough? Okay, good. So now that I know that I'm using the law of cosine, I need to get this, this, and this. That's what I need. Those things right there. Okay? So let's go ahead and get side C because I know the angle that's opposite side C. So if I'm going to start with this one, which equation am I going to pick, you guys? I'm going to use this one right there. Exactly. So I'm going to say C squared equals A squared plus B squared minus 2 times the 2 of those sitting right there times the cosine of the angle that's opposite, big C. So this is the law of cosines. So therefore, C squared is, A squared is going to be 4, because 2 squared is 4. B squared is going to be 9, minus 2 times 2 times 3, times the cosine of angle, 60 degrees. Oh, we know that one. That one's easy. So therefore, C squared is equal to 4 plus 9, how much is that?
13.
13 minus, let's see here, 2 times 2 is
Negative 12.
negative, all that together would be minus 12. Good, yeah. Okay, and then what's the cosine of 60 degrees? 1/2. Very good. That's where I was going to say. 1/2. Okay. So cosine 60 is 1/2. So therefore, C squared is equal to 13 take away 6. So C squared is equal to 7. Therefore, C is the square root of 7, which is approximately what, 2 point.
Cosine of 60 is 1/2.
Cosine 60 degrees. That's on the unit circle, bite size, right? Okay. So now this is the square root of 7, or about 2.6 that we have there. Then all we need is A and B. So which one do you want to get? Doesn't matter. Actually, we only need one, because then we'll subtract from 1A to get the other ones. So let's do cosine A is equal to, I'm going to use this formula here, you guys. A squared minus B squared minus C squared over negative 2BC. A squared minus B squared minus C squared over a negative 2BC. So the cosine of angle A is going to be, what, I got like 9 minus, what's B? So, oh shoot, that's not a 9, huh? That should be 4 minus 9 minus the square root of 7 squared, all over negative 2 times 9 times the square root of 7. So the cosine of A is going to be 4 minus 9 minus 7. How much is that? Did I lose, guys? So? Okay, 4 minus 9 minus 7, what do you got? 4 minus 9 minus 7, what is that?
Negative 5 minus negative 12.
Negative 12 over negative 2 times 3 times square root of 7.
Negative 7.
So when you plug all this stuff in, what do you get when you plug all this stuff in? Okay, this you get 0.76 and some change, right? Okay, so that's, therefore, the angle A is going to be the cosine inverse of 0.76, because we want A. So then A is approximately, I'm getting 40.9 degrees. Can you guys check to make sure that's right?
Wait.
Okay, so therefore, if this is 40.9, how do we get the other one? Yeah, subtract 180 minus 60 minus 40.9,
79.
and you get 79.1 degrees.